deep solar minimum is underway, and it may be the deepest of the space age. This is space weather latest. Solar minimum is here, but even now we have strangely beautiful auroras around the poles, north and south. Here's a beautiful image of the interstellar comet with its tail, captured with the backyard telescope by Gennady Borisov, the amateur astronomer from Crimea, who, by the way, built his own telescope to catch this. And you can see it right here. That's the tail right there. There it goes. Amazing. And we have deep solar minimum underway, the deepest one, perhaps the deepest of the space age, according to spaceweather.com. So far this year, the sun has been without sunspots 73% of the time, matching the record previously set in the year 2008. If the sun remains blank for the rest of this week, 2019 will edge past the space age record for sustained spotlessness. Sustained spotlessness, keeping an eye on the spotless days counter for updates. Now the tail we have seen here, the interstellar comet Borisov, the second interstellar object coming in 2 years. When interstellar visitor Huma flew through our solar system in 2017, researchers could not figure out where the cigar-shaped object was from, and ideas ranged from an alien light sail spacecraft to fossilized comets, and now another interstellar visitor has arrived, the 2I Borisov, and they believe it is somehow from one of the previous videos I just posted today, could be from the double red dwarf Kruger 60. That's where they believe the interstellar comet Borisov probably came from. Another interstellar visitor found by the amateur astronomer Gennady Borisov in Crimea. This October 11 video recorded by amateur astronomer Michael Jagger from Austria shows Borisov's tadpole-like tail very clearly. Now, captured on interstellar comet, backyard telescope, impressive accomplishment. Seemingly bright stars in the animation are actually quite dim, 8th to 9th magnitude, and they don't even have proper names. But this was nicely caught, as you can see. Now, what's the tail made of? And to answer that question, in September, an international team of astronomers led by Alan Fitzsimmons took a closer look using the 4.2 William Herschel telescope of La Palma in Spain. And they reported the results that they have found cyanide, of course. It looks basically like any comet that we would have in our solar system. Borisov's tail is rich in CN, cyanide. The comet's nucleus is pumping out approximately 4 times 10 to the 24 cyanide molecules every single second. That may sound extraordinary, but it's not. Here in our solar system, cyanide is commonly found in comet tails, and the production rate in Borisov is similar to that of our local comets in our solar system. Combining the production rate of cyanide with other factors such as the comet's brightness and apparent dustiness, the researchers calculate that Borisov's interstellar comet core is between 0.7 kilometers to 3.3 kilometers wide, and again typical of ordinary comets. And the authors also said, overall, we find the gas, dust, and nuclear properties for this first active interstellar object are similar to normal solar system comets. In other words, wherever comet Borisov came from, it must be a lot like what we have in our solar system. the All-Sky Fireball Network. Every night, a network of NASA all-sky cameras scan the skies above the United States for meteoric fireballs. Automated software maintained by NASA's Meteoroid Environmental Office calculates their orbits, their velocity, penetration depth in Earth's atmosphere, and many other characteristics. Daily results are presented here on Space Weather. And today we had a network reporting 8 fireballs. All, of course, inbound for Earth, intersecting at single point, Earth. Near asteroids, potentially hazardous asteroids, PHAs, are the space rocks larger than about 300 feet across that can come closer to Earth than 0.05 AU. None of the known PHAs is on a collision course with our planet, although astronomers are finding new ones all the time. And as of October 15, today, there were 2018 potentially hazardous asteroids. And the next one will be October 19th, approaching us at 2.5 lunar distances. The velocity is 5.8 kilometers per second, and it's about 30 to 40 feet in diameter. Cosmic rays in the atmosphere. We've developed, they say, a new predictive model of aviation radiation called ERAD, short for Empirical Radiation Model, constantly flying radiation sensors on board planes over the US and around the world, so far collecting more than 22,000 GPS-tagged radiation measurements, and using this unique data set, we predict the dosage on any flight over the US with an error no worse than 15%. ERAD lets us do something new, and every day we monitor about 1,400 flights crisscrossing the 10 busiest routes in the continental USA, and typically this includes more than 80,000 passengers per day. ERAD calculates the radiation exposure for every single flight, and there's a hot flight table. Daily summary of calculations shows the 5 charter flights, the highest dose rates, the 5 commercial flights with the highest dose rates, 5 commercial flights with near average dose rates, and 5 commercial flights with the lowest dose rates. Passengers typically experience dose rates that are 20 to 70 times higher than normal radiation at sea level. Space weather balloons also, once a week. The students of Earth Sky Calculus fly space weather balloons to the stratosphere over California. They're equipped with radiation sensors to detect cosmic rays, and it's a surprising down-to-earth form of space weather. Cosmic rays can seed clouds, trigger lightning, and penetrate commercial airplanes as well. And also, linking cosmic rays with, they are linked to cardiac arrhythmias and even sudden cardiac death in the general population. Our latest measurement shows that the cosmic rays are intensifying with an increased rate of more than 18% since 2015. The point data corresponds to the peak of the Renger-Pfotzer maximum, which lies about 67,000 feet above central California. When cosmic rays crash into Earth's atmosphere, they produce a spray of secondary particles that's most intense at the entrance of the stratosphere. Physicists Eric Renger and George Pfotzer discovered the maximum using balloons in the 1930s, and that's the way we're measuring today. And en route to the stratosphere, the sensors also pass through aviation altitudes. They show that the dose rates are expressed in multiples of sea level. For instance, we see that boarding a plane that flies 25,000 feet exposes passengers to doses rates 10 times higher than sea level, and at 40,000 feet, the multiplier is closer to 50 times that at sea level. Radiation sensors on board helium balloons detect X-rays and gamma rays in the energy range 10 kilowatts to 20 megawatts, and these energy plants a range of medical X-ray machines and airport security scanners. Why are cosmic rays intensifying? The main reason is the sun. Solar storm clouds, such as coronal mass ejection CME, sweep aside cosmic rays when they pass by Earth during solar maximum, and CMEs are abundant in cosmic rays held at bay. Now, however, the solar cycle is swinging towards solar minimum, allowing cosmic rays to return. Another reason could be the weakening of Earth's magnetic field, which helps protect us from deep space radiation. If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.